All right, class, we're going to take a look at section 3.4, which is verifying arguments. And so we're going to be taking a look at arguments that are a series of statements called premises, followed by a single statement called a conclusion. The argument is valid if wherever all the premises are true, then the conclusion must also be true. So we're going to be looking at collections of statements producing a conclusion. And instead of expressing them in sentence form, we're going to be looking at them symbolically. We're going to use, we're actually not going to be looking at truth tables. We're going to be looking at a list of validation for whether or not these are true. So here's the situation. So we've got Mahala passed the bar exam. Then, so if Mahala passed the bar exam, then she is qualified to practice law. Second statement, Mahala passed the bar exam. Based on what's happening here, if, then, so if the hypothesis, then the conclusion, she follows through, she's on the conclusion side, so that means she is qualified to practice the law. Sorry, I said the conclusion side, and this is she took care of the hypothesis side. That way she is qualified to practice law. So this works out symbolically. What we want to do is take a look at this, how it works with our symbolic. So we're saying P. P for passed. So if she passes the bar exam, then Q, she's qualified. Okay? She passes. So that insinuates then, therefore, she is qualified to practice law. Now notice this symbol down here is the 3 dots. You're going to see that in your assignments. The 3 dots mean therefore. 3 dots mean therefore in math. Okay? And that is our conclusion because it works. Here we go. Let's take a look at when these are true. So, oops, keep clicking, sorry. So law of detachment. This is how you'll know it's going to be true. So if you have P then Q and you get P, then you're going to get Q. So that's what we were just looking at in this previous situation. P then Q, you get Q. So in other words, if you have your hypothesis and your conclusion, and then you got the hypothesis to happen in the next statement, then you for sure will be getting the conclusion as your answer. So here we say, I've got P, and then, so I have a hypothesis, then I get my conclusion. If I have the negation of my conclusion as my next statement, then I can have the negation of my hypothesis. Here I've got a hypothesis, then conclusion, and then I've got my conclusion leads me to some other thing. If this brought me to here, and then that conclusion bringing me somewhere else, then going from the premise, the beginning, goes to the secondary conclusion. And that's called the law of syllogism. It might be called the transitive property in geometry. Disjunctive syllogism, you've got P, your hypothesis, and the conclusion. If you're then given the negation of the hypothesis, then you will get Q. Now there's some invalid arguments here. If you have the hypothesis and then you get the conclusion, and as a second statement you say, well, the conclusion is true, that does not mean the hypothesis was true. And then same thing here, fallacy of the inverse. So that was fallacy of the converse. Fallacy of the inverse is if you get your hypothesis and your conclusion in one sentence and you're saying, all right, well, I've got the negation of the hypothesis, that does not mean you get the negation of the conclusion. So these are invalid arguments. They do not work, and let's see how those play out here in real examples. So we're to identify the form of each argument. So your job is basically in your homework to have this list sitting next to you. Take a screenshot of it with your phone right now. Be a good time to do that. Push pause and do that. And then while you're doing your homework, as you read them, try to match them up with those previous pictures. So here, if we want to improve our cardiovascular fitness, then take up cross-country skiing. Okay, so you take up cross-country skiing. Therefore, you want to improve your cardiovascular fitness. So let's take a look at how this played out. We're improving our cardiovascular fitness, so we're improving. So if I want to, then I take up cross-country. So we're saying, all right, well, I took up cross-country. So therefore, am I improving my cardiovascular fitness? Well, let's take a look back at our last slide. This is saying I got my, sorry. I'm not looking at my hypothesis, then conclusion, and saying my hypothesis again. Here I'm down here saying I've got my hypothesis, I got my conclusion. Here's my conclusion again, so therefore I must have the first thing, right? Well, that's one of my invalid arguments. This is not necessarily true. So let's talk about it. So if I want to improve my cardiovascular fitness, I'm supposed to take up cross-country skiing, so I took up cross-country skiing. Does that mean that you wanted to improve your cardiovascular fitness? Well, it almost makes sense with a sentence, but think about it this way. Could I just take up cross-country skiing because I wanted a thrill? Could I take it up because my friends were doing it? Does that have anything to do with my wanting to be improving my cardiovascular fitness? It could, but not necessarily. So that's why this is an invalid argument. It's not necessarily true. You can't have a hypothesis and then your next step is your conclusion, and then that must mean the hypothesis was true. It's not the way that this goes. So fallacy of the converse is what we're looking at here. So now we're going to take a look at the second one. If you sleep through your morning math class, then you will be well rested. If you are well rested, then you will do well in your math class. So therefore, if you sleep through your morning math class, then you will do well on your math test. Well, sadly, the way that this is written, it's a valid argument, but obviously I'm hoping that's not actually what you're going to be doing with morning math classes. So let's take a look at how this plays out. If you sleep through your morning math classes, the hypothesis, this is our first P, then Q, you will be rested. And then we've got, all right, Q, then we will do well on our math test. And so we've got that property that we saw on the previous page that, okay, well, I can have P, then M, based on what I've got happening here. So let's take a look at the actual slide. This is S to R to W, therefore S to W, and this is the law of syllogism. This is a valid argument. It's a valid argument, but probably not a good idea to think that sleeping through the math class is going to help you do better. So let's draw a valid conclusion from the given premise. Okay? If a person gets hurt, then they will cry. Nikki isn't crying. Okay? So what this is doing, if we go back to our previous, well, let's draw it out first. So we've got, if a person gets hurt, then they will cry. Nikki is not crying, so she's not doing this. So what this would mean, based on one of our arguments before, she is not a person who got hurt. So let's look at how, if that's actually what our laws say over here. Oops, too far. So we've got, if person got hurt, then they will be crying. This person is not crying, and therefore she is not the person crying, or she is not a person who is hurt. So this is by the law of contraposition. Sorry. Here we go. So, and there it is symbolically. And so we want our law of contraposition here, and that is our actual valid argument. To make this a true statement, we want to say Nikki is a person who didn't get hurt. Okay. So hopefully that was helpful. Let me know if you have any questions through the Ask My Instructor